Hey, this is Avi Gutman with another Ask Me Anything event brought to you by quantreasoning.com. I invite you to join me live next time. We do this every Saturday at 11 a.m. Eastern, and you can attend for free by starting your free trial at quantreasoning.com. I'll start with statement 1 because they seem pretty similar. Statement 1 tells us that one of the piglets, call it Piglet A, was fed exactly a quarter of the total oats. Now, we also know that each piglet got half a pound of the mixture. So what I'd like to ask all of you to do here is not only think about whether the statement is sufficient on its own, but also think about any inferences you might be able to make about what could the number of piglets be. Is it really anything from 1 to infinity, or are there any limitations given statement 1? And I also want you to think about the total possible amount of oats. Could there be an infinite number of pounds of oats available that day, or is it limited in some way? We know from the free info that each piglet was fed a total of half a pound. So at the extreme, if Piglet A only got oats, that would be half a pound of oats. And if that's a quarter of the total amount of oats, then there must be 2 pounds of oats. Now in reality, we know that Piglet A got less than half a pound of oats because we were told that each piglet is fed some of both grains. So if Piglet A got less than half a pound of oats, and that represents a quarter of the total amount of oats, then you've got less than 2 pounds of oats. And this inference doesn't change my answer about statement 1, but we're not just here to answer the question, we're also here to learn how to make inferences when possible. So statement 1 tells us there's less than 2 pounds of oats. What about the number of piglets? Is it possible that does statement 1 allow for the number of piglets to be 1? Could there be just one piglet? You see, if Piglet A was fed a quarter of the oats, who was fed the other 3/4 of oats? Somebody was fed it. So can we say that there must be at least 2 piglets?
No, but it could have been just thrown out, right?
Of the oats today. So that language lets me know that the oats we're talking about, a quarter of what? A quarter of the oats that were fed today. Fed to whom? To the piglets. So if we were looking at the total amount of oats that were fed today, and we know that a quarter of those were fed to Piglet A, well, the other 3/4 would have had to be fed to some other piglets. I don't know whether there's only one other piglet that got 3/4 of the oats, or whether there's a million other piglets, each of which only got 1 grain of oat. I don't know how much 1 grain of oat costs, and maybe they could even get 1/10 of a grain if there's a special knife that can chop up the grains. I don't know. So there's no upper limit to the number of piglets with statement 1 on its own. But there is a lower limit, and that lower limit is 2. There have to be at least 2 piglets. When they say of the oats today, of the oats what today? Of the oats cooked today? Of the oats that arrived today at the farm? Well, it doesn't say anything like that, so I guess the word fed is implied in here, because there's no other option in the sentence, so it's implied. That's probably what they would say if it was a sentence correction answer. So what do we know so far? From statement 1, we know there are less than 2 pounds of oats total. That's a big inference that most people miss. And there are at least 2 piglets. So at least 2 piglets. That's from statement 1, but we don't know how many piglets there are. The question was, how many are there? We don't know. Eliminate the answer choices that claim that statement 1 is sufficient on its own. Statement 2 is very similar. What limitations does statement 2 provide on the number of piglets and on the total amount of barley. What can we say about those things? Yeah, I'm seeing some good answers there in the private chat. There must be less than 3 pounds of barley total. There must be less than 3 pounds of barley total. That's what statement 1 implies, because in the extreme, if Piglet A was only fed barley, Piglet A would get half a pound of barley. That's at the extreme. Now we know that Piglet A was not fed half a pound of barley. It was definitely less than half a pound of barley. So if less than half a pound of barley represents 1/6 of the total amount of barley, then guess what? There must be less than 3 pounds of barley. Piglets, same as statement 1. It implies there's at least 2 piglets. But that's all we can say about the number of piglets with statement 2 on its own, so I'm going to go ahead and eliminate B. When we combine the statements, I suppose we could still say that there's less than 2 pounds of oats and there's less than 3 pounds of barley, which would mean there's less than 5 pounds total. And that does give us an upper limit on the number of piglets. So this is significant, right? The piglets now do have an upper limit, whereas they didn't have an upper limit with each statement on its own. What is the upper limit for the number of piglets when we combine these statements? We know that each piglet got a total of half a pound, but we also know that the total amount of oats is less than 5 pounds, because you got less than 2 pounds of oats and less than 3 pounds of barley, so total less than 5 pounds. And we know each piglet got half a pound, so there must be fewer than 10 piglets, exactly. So there's at most 9 piglets. So a lot of people would say here the number of piglets has to be no more than 9 and no fewer than 2. And that gives us how many different possible answers? A lot of people would say 7 here, but actually it's 8. There are 8 different possible answers. You can count it on your fingers, right? 2, 3, 4, 5, 6, 7, 8, 9. Or you can move the range down the number line to start from 1. So instead of going from 2 to 9, it would go from 1 to 8. So I just moved the range 1 down the number line. It's easier to see it when you're starting to count from 1. And then there's also a way to do it that I talk about in the book, but I won't go into that here. So there's 8 different possible answers, and then they would pick E, which it turns out is not the right answer. So there is one additional inference that we can make here that we haven't made, and that's what makes this question so interesting and so difficult. Hey, I'm just going to interrupt my own video for a moment here. If you're finding value in this video, please let me know in the comments below, and give this video a thumbs up. It really motivates me to keep uploading a new video every day. Alright, back to the video. When we combine these statements, what can we say about the fraction that Piglet A receives out of the total amount of grains, if anything? Is it possible? Can you imagine a scenario where we have these 2 statements and turns out that Piglet A gets 1/10 of the total amount of grains, which would mean there are 10 piglets, right? If Piglet A gets 1/10 of the total amount of grains, that would mean there are 10 piglets. Is that possible when we combine these statements? Is it possible that in total, Piglet A receives 1/10 of the total amount of oats? And if not, why not? I'm sidestepping the number of pounds here and just saying if Piglet A receives 1/10 of the total amount of grains, then there must be 10 piglets, because we know each piglet receives the same total amount. The internal ratio of what they're getting is shifting, but if you're just looking at, hey, how much grain, if you don't care about the type of grain and you just say, hey, how much grain is each piglet getting? Every piglet is getting the same amount by weight. Like if you put them on a scale, every piglet is getting the same amount of grain. So if Piglet A gets 1/10 of the total amount of grain, then there would be 10 piglets. Is that understood?
I think that's where I'm struggling.
Try to forget about the pounds for a moment and just imagine you've got a certain amount of grain. So try to forget about the distinction between oats and barley. They're both grains. So try to forget about that distinction. imagine that they look the same and you can't tell the difference. So you're not a piglet farmer, you're just a city guy showing up at the farm on some kind of field trip. And the farmer greets you and says, hey, look, these are my grains that I feed my piglets. And all you're seeing is just a whole bunch of grain. You don't know how to distinguish that there's two different types of grains. So however much amount of grain the farmer has, each piglet is going to get the same fraction of it, because we're told that every piglet receives exactly half a pound of mixture. So every piglet gets the same amount. If there's 10 piglets, each piglet will get 1/10 of the grain. This is where we're kind of imagining that there's no distinction between the types of grains. Instead of calling it oats and barley, just call it grain. There's just grain. There's a certain amount of grain, and every piglet gets the same amount. So it's just a simple division exercise. Whatever the amount of grain is, you divide that by the number of piglets, and that's how much each piglet gets. It turns into a very simple division exercise.
Okay, so if I had like one bar of chocolate and everybody gets 25%, there must be 4 people. Is that what you're saying?
Exactly what I'm saying. Yeah, it's a much simpler question then. If there's no oats and there's no barley, if there's just grain, if grain is grain and that's all there is, then if we're told that each piglet gets 1/10 of that, then there must be 10 piglets. And my question was, is that possible when you combine these statements? Is it possible that each piglet gets 1/10 of the grain, given that each piglet gets a quarter of the oats and 1/6 of the barley? Is it possible that overall they're getting 1/10 of grain? And if not, why not? And maybe I can give you an analogous question. If I have 2 investment accounts, and in investment account A, I made 8%, and in investment account B, I made 20%, is it possible that overall I made 45%? And here's another analogous question. If I'm a bartender and I'm mixing different drinks together, so I've got this one type of alcohol that's 6% alcohol, and this other type that's 20% alcohol, and I'm mixing them together, is it possible that the cocktail has 40% alcohol? When you mix two things, the result has to be somewhere in between. So with the 6% and 20% alcohol, the cocktail should have somewhere in between 6 and 20. Where exactly in between 6 and 20? Well, it depends on the quantities of the different types of alcohol that I used. What about my investments? Right? If one investment made 8% and the other investment made 20%, I don't remember the numbers I used, let's say 8 and 20, well then overall I must have made somewhere in between 8 and 20. Closer to 8 if there was more money invested in that account, closer to 20 if there was more money invested in the other account. It's a weighted average. So what inference can we make now when we combine the statements about the possible range of overall fraction of the total grain that Piglet A received?
It had less than a fourth of the total grain, but more than a sixth of the total grain.
That's right. You know, this reminds me of a story that I told maybe 6 months ago in one of these AMAs about my dad's age, the ratio of my dad's age to my age. Some of you may recall this. On the day that I was born, my dad was like 10,000 times as old as me, because he was 26 years old, which is approximately 10,000 days, and I was 1 day old, so the ratio of his age to my age was 10,000 to 1, approximately. And as time went on, he and I aged by the same amount, because when 1 year passed for him, 1 year passed for me. We both became a year older, but the ratio of our ages dropped very significantly, so that by the time that I was 26, by the time I was the age he had been when he had me, the ratio of our ages was 2 to 1, because he had lived 26 years twice, and I had lived 26 years once at that point. So it went all the way down from 10,000 to 1 to 2 to 1, and since I turned 26, it continued to drop. Now he's only like 1.5 times as old as me. And the reasoning there, why that was happening, is because we started out with a ratio of 10,000 to 1, and then we kept adding to both the numerator and denominator of the ratio we were adding a new ratio of 1 to 1. Why was it 1 to 1? Because we were aging at the same pace. When 1 year passed for him, 1 year passed for me. So the rate at which we were aging was 1 to 1. And when you're combining ratios like that, the result is always going to be somewhere in between. And that goes for the alcohol example and the interest example and also this piglet example. You're adding, if we call this Piglet A got oats A, that's the amount of oats that Piglet A got out of the total oats, and B for barley, BA, that's the amount of barley that A got out of the total barley. Let's call it OT, O total, oats total and barley total. OA plus BA, that's the total amount that he got out of OT plus BT. That new ratio has to be somewhere in between the original two ratios. And we know from statement 1 that this is a quarter, and we know from statement 2 that this is 1/6, and the combined ratio has to be somewhere in between. And this I've seen tested a ton on the GMAT. They even test it in a question that probably looks more like number properties question, where they say if A, B, C, and D are positive such that A over B is greater than C over D, which of the following must be true? Does this look familiar to anyone? One of the options, let's call it Roman numeral 1, says A plus C over B plus D is less than A over B and greater than C over D. And this must be true for the reason that we were just talking about. We have two ratios, a big ratio and a little ratio, and we're only dealing with positive numbers, so there's no complications there in terms of the sign. And when we combine the ratios in this kind of manner, the result has to be somewhere in between the original ratios. It's a weighted average again. So this question looks totally different from the piglet question and totally different from the example about alcohol or the interest that you get on an investment, but they're all testing the same concept. Another example would have been average speed. And you've got your average speed on the first leg of the trip and your average speed on the second leg of the trip. Overall, the average speed for the trip has to be somewhere in between those two average speeds of each leg. And the same goes for this Piglet A. If Piglet A got a quarter of the oats and 1/6 of the barley, then total from grains, Piglet A must have got somewhere more than 1/6 and less than 1/4 of the total grain. And that's a concept. It's not the only way to solve the question. We're about to see another way that I think is maybe easier, but we wouldn't learn as much from the second way that I'm going to show you. And I think if we want to learn from this question, this is the lesson that we need to learn. That when you're combining ratios, the result has to be somewhere in between the original ratios. Now that we know that Piglet A received less than a quarter of total and more than 1/6 of total, and remember we wanted to know how many piglets are there. But we know that whatever the number of piglets is, let's just call it n for a moment. If there are n piglets, each piglet receives 1 over n. So if n piglets, Piglet A, as well as every other piglet, gets 1 over n of total. So you can now say that 1 over n is more than 1 over 6, but less than 1 over 4. What can n be? There's only one option. You've got 1 over some integer that lives between 1/6 and 1/4 exclusive. It's not 1/6. We know it's not 1/6. We know it's not 1/4. It has to be 1/5. N equals 5. And that's why the correct answer is C. So that's one way to solve this. I think the constraints that people tend to forget about here are, one, the number of piglets has to be an integer. So there's an integer constraint there. And 2, actually there's 3 things people forget. So that was 1. 2 is that every piglet gets exactly 1/2 of a pound. And that has some significant implications, as we saw earlier when we evaluated each statement on its own. And the third one is that every piglet receives exactly the same amount. So whatever the number of piglets is, the total amount of grain divided by the number of piglets gives you 1/2 pound, because each piglet gets 1/2 pound. So quite a few constraints here, and that's why turns out that there's only one possible scenario when you combine the statements. So if it wasn't for all those constraints, then it would be an easier question, because the answer would be E. The other way that I think is quite interesting to solve this question is to draw a number line, of course, and let's call this number line the oats number line, and I'm going to have another number line for barley with 0 here on the left, and I'm going to say something like this. If this is the total amount of oats, I'm going to put a little tick mark there in the center, and then another one here. This is Piglet A. Piglet A gets 1/4 of the total amount of oats. Does everybody agree? Put another tick mark there. So 1/4 of the total amount of oats. Let's do something similar for barley. So if we say the total barley is there, let's imagine that that's 6 equal segments, and 1/6 of the total amount of barley. That's what Piglet A gets. Now we know that if we were to add these together, that's 1/2 pound. And I want to make some kind of inference here, so what can I do? I'm thinking if I quadruple, that would take me here. That's quadrupling. So that amount should be 2 pounds. I quadrupled the oats that Piglet A gets, and I quadrupled the barley that Piglet A gets. Notice though that I still have 1/3 of the barley, or the total barley, left over. So we have 2 pounds plus another 1/3 of the barley. You can also do it algebraically if it helps you. We know that 1/4 O plus 1/6 B is 1/2 pound. And so if you quadruple, if you just expand that equation by a factor of 4, you get O plus 2/3 B is 2 pounds. I prefer it visually, but you could get there algebraically as well, and then you would say, okay, but I still have another 1/3 of B, question mark. I don't know about that. But that's not true. I do know something about 1/3 of B. I know that 1/6 of B is less than 1/2 pound. Remember that from when we were evaluating statement 2 by itself? If 1/6 of B is less than 1/2 pound, then 1/3 of B would be less than 1 pound. But it's certainly more than 0. So we've got already 2 pounds here. And now we're saying there's a little bit extra. It's more than 0, but it's less than 1 pound. How many could it be? How many pounds could it be? Could it be 1/4 pound? So you'd have a total of 2 1/4 pounds? No, there's an integer number of piglets multiplied by 1/2 pound each. The total amount of grain has to be a multiple of 1/2. So 1/2, 1, 1.5, 2, 2.5, 3, 3.5, 4, etc. And if we know that this excess of 1/3 of B is more than 0 and less than 1, well, then it has to be 1/2 pound. And so now we know the total amount of grain, and we can infer there must be 5 piglets. So this is I think it's the easier way to solve the question. I believe so. Because it doesn't require that really tough conceptual abstraction of realizing that the total fraction of grains that Piglet A got is somewhere in between the fraction he got of the oats and the fraction he got of the barley. Because that's a tough thing to wrap your head around. And I think this solution is maybe easier in that sense. So I think either of those two solutions is really hard, and then that makes this question very hard. And that's why we spent a whole hour on it. If you found this video useful, go to quantreasoning.com for a lot more where that came from. You should also click that like button and let me know in the comments below what you'd like me to make future videos about. And of course, if you haven't yet subscribed, go ahead and do that and click that bell below so you get notified about future videos. See you next time.